Well, good evening, everyone. My name is Arthur Demerich. I'm the director of the Lemelson Center for the Study of Invention and Innovation, and I'm really delighted to welcome you to the National Museum of American History. We're in the process of a multi-year renovation and renewal process, and you can see that exhibited here. This is the first of what will be several new renovated wings to the museum, and so this is very much an innovation-themed wing that has a series of exhibits that we'll encourage you to look at after the discussion, including to your right, or to my right, to your left, Wonder Place, and next to it, Spark Lab. These are places where we really are trying to engage kids. Wonder Place to give kids an impactful and positive museum experience very young, because it turns out later in life, the people who like to come to museums are ones who did it as a child and enjoyed it. Next to it, Spark Place, a place where kids do hands-on inventing activities. And this year, we in fact have an Inventing Green theme that's around the environment. We have activities where they try to invent things that will help the planet. And so we're continuing on that theme through the year. Next to that is an exhibit called Places of Invention, which is about the role of tech clusters through history. And I think it's interesting to think also of your own home communities. What's being invented there, and how are they places where people collaborate and invent new things? And then over here, we have this very large and important exhibit on American enterprise, showcasing the history of American business. And of course, the agribusiness is front and center, is at the core of that. So before coming here, I used to teach at Harvard Business School, and we would teach a case on international trade and competitiveness. I used to enjoy asking the students and say, what is America's competitive advantage in international trade? And they would always go to technology, which is kind of true, but actually it's agriculture, where we are the low-cost, large-volume producer of the world. And that's really only possible because of the technological advances of the people in this industry and some of the people on stage. In coming years, we're going to be opening new exhibits on the second and third floor. On the second floor, about immigration and democracy, about the peopling of America, and about America as an innovative nation itself. And on the third floor, new exhibits will come the year after that on pop culture, music, and the arts. And so we're really integrating this concept of innovation across the museum and in some new ways. But our core has been, as a museum, the history of technology. And the topic we're engaging tonight is very much to understand change over time and to give people a deeper perspective on the present and ideally help prepare people for the future. And that's in a way what the Lemelson Center is about, and it's increasingly what our museum's about. The program tonight is a signature event on its own. It's also part of a series we call Innovative Lives. And they aim to explore an innovator's background, the challenges they've encountered, the obstacles they overcome, and their unique perspective on the process of invention and innovation. So it's not so much about the bright light going on, but understanding innovation as a process and as a sequence. It takes organization, it takes a vision of the market, and it takes the ability to modify and adapt with some variation. And interestingly, how we innovate has been changing over time. So if you think about the organization of R&D in the early 20th century, you get the first industrial research, and yet it's set up very much like a university system. In the mid-20th century, we get the building of these academic laboratories, both in academia, but then also in the private sector. So these kind of pristine labs out in the middle of nowhere, research campuses. More recently, it's been open innovation models and bringing it back into the cities, connecting it to the universities. And so there's an interesting question here, how that changes the core research that's done in the ways that we organize it. And then there's one other thought about tonight's workshop, which is, there's been few areas of technologically driven change that have generated as much interest, protest, and concern as that of genetically modified crops. And so for a museum like ours, that's front and center, interested in these issues at the forefront of science and society, these are actually really interesting debates because they're about technological and technical risk assessment, but also about how we organize our society and our economy. So in the space of about 70 years, we shifted as a country from about 30 to 35% working in agriculture to less than 3% today. And that's been a stunning transformation. We've done that without everyone becoming unemployed. And yet there's an incredible anxiety at present about the robots coming for our jobs, about artificial intelligence wiping out. And the perspective on that is not what's going to happen. We're going to find new and interesting creative industries, We'll continue to be a technologically driven society, but we will change what we need to do in terms of work. And so that's a kind of interesting concept to explore as well tonight. And then last, we haven't really quite resolved this core tension in GM food. The supporters of GM agriculture draw on this point. It's impossible to feed the world's population using older farming techniques, technologies, and equipment. We need to continually improve the technology. But GM food has raised some concerns about the farming system and about risk and safety. And so it's quite interesting to see this concern that government subsidies are supporting GM crops, that cheap industrial food somehow harms humans or undermines natural environments. And the solution we keep hearing is more inclusion in technical risk assessment, in changing how we decide what does and doesn't come on the market. But of course, our way of testing products is based on laboratory and animal tests, and in those, GM foods have never been shown to cause harm. And so there's this interesting tension, we'll see to what degree our panel thinks about this, between the technical risk assessment and the way the public has been tending to perceive this area. So I'm delighted to be able to introduce this panel and to welcome everyone. The discussion you're about to hear in an event like this is really only possible with outside support. So I'd especially like to thank this evening's supporters, the U.S. Farmers and Ranchers Alliance, and the Alliance partners, the CropLife America, Monsanto, and the National Corn Growers Association. And so with that, I'm really delighted to introduce Randy Kratz, a good friend of the museum and the CEO of the U.S. Farmers and Ranchers Alliance. He brings some 25 years of experience from the food and agricultural industries, where he's had positions in agribusiness leadership, public relations, product management, branding, online marketing, advocacy management, and communications. Lots of great jobs. I'm impressed. He's worked for and represented many of the well-known food companies, and he's a graduate of Kansas State University. I used to teach at KU, so we can get into that later, but anyway, he continues to play an active role on the farm where it says online where you were raised, but I think it's where you grew up. Anyway, welcome.
We are thrilled to be, it's almost like a partnership, and I'm not supposed to use that term, but we love the association that we have with the Smithsonian, and it's actually been ongoing for some time now. We produced a film 2 or 3 years ago called Farmland that we've shown here at the museum that now is available through Discovery Education and basically available to every high school student in the country at a website called discoveringfarmland.com. And our relationship here is so meaningful. My dad is almost 86 years of age, went through the museum here 22 years ago with me. And it's, his first 4 harvests were with horses. And it's great to be able to talk about the history that exists in agriculture with him, and I still kind of live it when I get to talk to him about the good old days, right? And it really is meaningful for me. I wanted to tell you just a little bit about our organization because that's so important and really a big piece of why we're a part of these types of relationships and why we step in to opportunities that are presented to us like this. USFRA is a 6-year-old organization. We were originally created to help bridge the gap between consumers and farmers and ranchers, and that gap that now in some cases, depending on where you are in the country, is 4, 5, and even 6 generations from when people had direct knowledge and were maybe on a farm or more directly involved in agriculture. So we have a big job to do. It's not uncommon for me to, and we were talking earlier, it'd be fun to kind of write down the quotes that you hear from people that maybe don't have a strong appreciation or even any understanding of all of what goes on the farm. I recently bumped into a young woman that talked to me about when she ate meat that had been fed GMO corn, that she got a rash on her chest. And maybe she smelled the hormones that were being cooked from the pork that was in a restaurant. And so there's just so many things that we need to do to continue to bridge to consumers and help them understand really what goes on in agriculture. And until we do that, we've got a long road ahead of us. And we do it with the Farmer and Rancher's Voice, everyone. So we're made up of 104 different farm organizations. many of them national, many of them state organizations, also in the ag industry. We're very proud of what we are, and the goal is to earn trust of the consumer, right? That's what we work toward every day, and we run consumer programs to do that. We also know that on our budget, you can't talk to every consumer, so we try to speak to people that we call the consumer food connectors that carry a little bit more weight and more influence in the food industry. And also, we do events like this because we see you all as super influencers, and we need to be a part of this. Yesterday, I spoke at an event in Chicago at Food Tank. We've recently been at events with the Wall Street Journal and the New York Times, South by Southwest. So we put farmers places where farmers generally aren't and where their voice might not be normally heard. And it really does make a difference, and it's very engaging for the farmers and ranchers. It's also a great opportunity for consumers to understand more clearly what we do. So I don't want to take my allotted time, but I did want to familiarize you all with who we are and that we're out there every day in digital and social spaces working to connect farmers and ranchers to consumers and trying to do it in very unique ways. I'm particularly proud of this relationship. I'm very proud of what we do with students across the country. And then, of course, whether it's registered dietitians and nutritionists or actually physicians, we have so many ongoing programs to help people understand what's going on the farm. And lastly, just recently, last week, we launched a program called Smart Farm. And the idea here is that through our research, we found out that millennials really are attracted to conversations about technology. So we tested it a couple of times and went pretty deep into young millennials to make sure that what we were seeing was true. And it really does come down to bear that when we talk about the innovation that goes on a farm, first of all, there's very little understanding. And secondly, there's a great desire to grasp what's going on. You know, only 13% of people graduated from college today see themselves going into someone else's business. They see themselves as entrepreneurs today. So farming and agriculture is extraordinarily interesting to them, and we feel like this smart farm concept to help people understand why we confine livestock and how we can monitor livestock and keep them healthy, why we use antibiotics, why farmers choose to grow organic, or why they might in fact use GMOs or other more advanced technologies. So it's been a great experience for us. We're so glad to be here, and Peter, thank you so much for continuing to work with us. And I'll kick it over to you. And Peter Liebhold is the curator, one of the curators here at the museum, and has walked me through this exhibit a couple of times. And I just enjoy it so much when you're the one that leads us through it. And thank you for letting us be a part of this.
Great. Thank you very much. So I think this is going to be a really exciting evening. We're going to try something sort of novel and different tonight. I mean, oral history is really, we're doing oral history in front of a crowd. But we're also going to go old school, and I've got some visual prompts that are laminated. All the teachers in the audience will appreciate this, so that my guests on the stage can see them. But up on the screens, you can see images. So you get to see the giants, the pioneers of plant science. I mean, this is sort of, I can't tell you how exciting of an opportunity this is to have Mary-Dell Chilton, Rob Fraley on the same stage is really an honor. But you'll also get to see pictures of them, so this is kind of cool. So first thing that I just wanted to say, you can look at the images together because you can't. I did want to reinforce this notion that the United States has this incredible connection to agriculture, that at founding, over 90% of the population were farmers or had a connection to farming. Today, that it's less than 2%. And that while farming has become efficient and the number of people isn't so great, the production is still very high. And most importantly, the mythos of the nation, that we think of ourselves as agricultural. And so it's really important in terms of the country that developments in plant work is something that touches everybody today. The next image that you'll see is Phil Bradshaw, who's in the audience, standing there, the modern American farmer with high-tech soybean feeds. And what's important about this is that farming today is a $177 billion industry. And it's one of our major export crops, over $20 billion in trade surplus. And so this is amazing stuff. Farming really does matter. And our guests today are the people that really have made many of these advances possible. That these are truly the pioneers that have in terms of plant science, have taken us into a new age. And that age, of course, is genetic engineering. And hopefully they're going to do most of the talking now. I'll just ask them an occasional question. But one of the things that you all might think about as they're chatting is sort of the overarching questions. The notion of what is the course of science discovery? Because neither Mary-Dell nor Rob are farmers, they're scientists. And so this is how we deal with science. How does science discovery work? What motivates discovery in the United States? The whole notion of innovation is really important, and what drives innovation. And I think that they'll have some insights in terms of that. And then lastly, this overarching question of, are we a science-based society? That is this how we think? Is this how we decide things? And where we are today. Now, with that as background, it's important to remember that genetically engineered plants did not happen in a moment. It was not like a eureka moment and suddenly they happened. That this was years and years of work by scientists from around the world. That why you two guys are some of the most important folks. There are other folks involved as well, and I'm sure they'll mention some of those. But before we go into that, I really want to learn just a little bit about the two of you, who you are and sort of what makes you tick. So our first image here, Mary-Dell, you get the first question. So this is a young Mary-Dell, and whenever you read about Mary-Dell, she often makes the joke that she's nearsighted, both physically and metaphorically. And we can't help you in terms of, you've got the glasses, you can fix this sort of being able to see stuff. But the metaphoric part of it is really interesting. That I've read where you said you didn't have a clear vision for the future, that you spent a lifetime of doing what amuses you. And for me, this sort of launches a natural question of, is science education in the United States good? Do you think that you were well served by your education, or did you achieve to become a science pioneer in spite of your educational background in terms of your early public school education?
You're asking me that now?
Yeah.
Gosh, I don't know. I know I went to Catholic school through the 4th grade, and when I moved to public school in the 5th grade, they gave me these standardized tests to figure out what to do with me. And for the first time, I recognized, looking at my scores, that I must be bright. I had never realized that. I was reading at like the 11th grade level, and mathematics a couple of grades ahead of where I was. And I don't know whether it's a good thing or a bad thing for a bright kid to realize that there's something special about him. I think bright kids today probably are recognized and told that in a way that it wasn't the fashion or it wasn't the practice when I was a youngster. I didn't find science. Science kind of found me, but not until high school, not until I was a freshman in high school. But certainly the education that I had beyond that bent me in the direction of all the stuff that came later. How about Rob?
we're going to give Rob a different question. So here's Rob's question, or here's Rob's picture. And unlike you, Mary-Dell, Rob grew up on a farm. And one of the things is a picture of Rob on a tractor. And looking at this picture reminds me of a story about Henry Ford. Henry Ford, in 1879, left the farm as a 16-year-old and moved into the city to apprentice as a machinist because he hated farming. He despised it. You know, there are different things for different folks. But what's interesting about this for Rob is a story I've once heard, and I don't know if it's actually really true, that your grad school bench partner, Don Luking, remembers you saying, "I don't want to ride the tractor back and forth for days at a time ever again." So one question is, A, is the quote correct? And more importantly, do you think your childhood history on the farm actually affected your work as a scientist?
Oh, absolutely. I mean, you know, growing up on a farm was, you know, it's a remarkable experience. I mean, I think your connection to, you know, the challenges that farmers face, you know, gets ingrained. I was really fortunate. You know, I was one of those weird kids that knew he was going to be a scientist from the time I was 5 or 6 years old. You know, I would, you know, I think we had the World Book encyclopedias. I would go through and I would copy pictures, and I would take things apart in my dad's workshop. So, you know, I always knew I was going to be a scientist. You know, agriculture for me was fascinating. It wasn't really an option. We had a really small family farm in central Illinois, and it barely, you know, kept our family going. So, it wasn't easy for me to go back to school and from school to get into farming. But in many ways, I don't think I've ever left farming. I've been involved with it all my life. I actually have a couple of farms in different parts of the country. But, you know, so there's that whole prep thing, and then there's all the things that happen by accident. For me, I just say two things. I went to a real small school. When I graduated from high school, there were 18 in my senior class. And I got the special attention of a really, you know, impactful high school teacher who turned out to be my biology teacher, my chemistry teacher, and my physics teacher. And I think I was the only person in all three classes. So I knew that was going to be the key. And then, like a lot of accidents that happen, I got a phone call one day to do postgraduate work in a special place in California, UCSF. And the significance of that was UCSF was where the whole biotechnology world started. You know, Herb Boyer and Stan Cohen did the first gene transfer, the first recombinant DNA experiment in the mid-'70s. I got to UCSF in '78, and it kind of wrapped everything back together, which was how could we use this new science of biotechnology to help farmers and improve crops. And that was, for me, coming full circle.
Well, you took part of my next question, which is a good thing. So here we've got images of you have to share on this one because you get the same slide for both. But one of the things about science
my kids love that mustache. They keep asking me about it, you know.
Yeah, it could make a comeback.
And here we are in November.
I sort of like the hair.
Yeah. Hair is really overrated.
A university research lab, I think, is something that's really important, and really interested in hearing your comments about a research lab. It's more than just four walls and equipment, but it's also a community and a mentoring system. Both of you had really interesting experiences in terms of selecting your grad school and the labs that you went to work with. Dr. Chilton, I think that you decided to work with Ben Hall and followed him from University of Illinois to University of Washington, right? And Dr. Fraley, you were with Dimitri Papadopoulos in New York, but then went out to California. So what I'd like you to think about is you know, we deal with role models, and what kind of experience was this for you? what did the decision about a research lab really mean to you? How did you decide who to work with, and then did that start your course in terms of who you would be as a scientist?
I was in graduate school. I was a year into graduate school, and I took a course that dealt with DNA. It was called The Chemical Basis of Biological Specificity. And I loved everything that I learned in that course. And Ben Hall was the only professor in the chemistry department who did anything with DNA. He was studying DNA as a macromolecule and not as much into the genetic aspects. But after I had worked with him for a short time, he told me that he was moving to a genetics department at the University of Washington. And I thought that sounded terrific, a whole new field to learn about. I was drawn to DNA, and the genetics department is the right sort of place to work on DNA. So the choice was simple for me. I was wildly enthusiastic to follow him out there.
Rob, what was your experience like?
Some good planning and a little bit of serendipity, like most things. So I finished up my PhD at Illinois. I was really intrigued again with this question of gene transfer in plants. There was a lot of science at the time that said maybe a way of getting genes into plant cells was at that point in time, no one had ever put a gene into a plant or figured out how to do that. And I was interested in a whole line of research at the time where scientists were packaging DNA or RNA into liposomes, artificial membranes, and fusing those to cells and using that as a vehicle to put the gene inside, because that's the starting point in all this. And one of the experts in the world at the time was Dimitri Papadopoulos, and he had a laboratory in Roswell Park in Buffalo, New York. So I'm just getting ready to get married and leave Illinois, and I'm explaining to my wife that we're going to have this wonderful 2 or 3 years in Buffalo, New York. And the day we visited Buffalo was like after one of those record 200-inch snowfalls or something, and we were going from building to building in snow tunnels. So that was going to be the plan. And then I'm back in the lab, and about 3 weeks later, after I agreed I'm going to go to Buffalo, Dimitri calls and says, "I got good news and bad news." And I go, "Well, what's the bad news?" "Well, I'm moving my lab." "What's the good news?" "It's going to be San Francisco." So we went to San Francisco, and for me that was the magic, because our laboratory, Dimitri's laboratory, was on the 12th floor. Herb Boyer's laboratory was on the 10th floor. Here's the guy who created recombinant DNA. Bill Rudder's lab was on the 9th floor. He was the guy who helped clone the insulin gene and create the first GMO product, GMO insulin. And what I learned out there was pretty phenomenal. I mean, in terms of what was possible, but I think it also intertwined the public-private interface that I think was so important, and really in many ways I think separates a lot of the key institutions, and in many ways is the real strength of R&D in this country, is how do you bring the leading edge of science together with the development and turning outstanding science into products. And you could see that evolving across the Bay Area in human health care, as basically the GMO technology has transformed human health care. Today probably 50 or 60% of the new pharmaceutical products are GMOs or GMO derivatives. And my passion, again, was how do we make a better crop?
Great. Well, one last real science question, and here we've got an image of crown gall. This will certainly bring a smile to your face.
That's a really ugly one there. You have much better ones, I know, in your pictures.
The science labs are really interesting because they're based on both collaboration and competition. And what I'm really interested in here as scientists, here you talk about this notion of when do you collaborate and when do you compete? How it's a fairly small community of people that were working with agrobacterium and this area. What was that interaction like?
It was very competitive. Not to say there was no collaboration, but in the early days, I moved from Seattle, from the University of Washington to Washington University. And the first thing that happened was that Ernie Jaworski, that's a very important name that should be stated here. Ernie was the director of, what was he? Do you know what his title was?
Biological sciences
Yeah.
at Monsanto.
Anyway, he gave me, free of charge, stipends for 2 postdoctoral fellows to start my lab. I walked into Washington University and I had 2 empty labs and a bunch of boxes and 1 work-study student. That was my research group in 1983. And Ernie gave me these 2 postdoctoral fellowships. And that really got me off and running right away. One time when I was giving a seminar, somebody asked me how it was that I had identified such excellent postdocs. And I had to admit that I let everybody that I could pay in the door, first come, first served. It was really the project.
It was the excellent instruction, I think.
The project was good. The time in the agrobacterium story was wonderful. Everything was moving so fast. So let's see, did I get off the topic? We were coming to the interaction, the collaboration part. The collaboration of Monsanto with the Chilton lab was money coming into the lab and to some degree information and ideas and advice coming out of the lab. I helped them recruit this stunning scientist next to me. Rob, you remember that?
Yeah, when I first went to St. Louis, I think I spent the first 6 or 9 months in Mary-Dell's lab, which is pretty cool.
Say, yeah. You spent some time.
Mary-Dell showed me how to isolate the TI plasmid.
You spent some time visiting my group meetings, as I recall, even thereafter.
Yep.
So was that collaboration or was that competition?
I don't know.
It was a little bit of both. I mean, what I remember, you think about how anything happens, and you always build on the knowledge that comes before you. And we were in an interesting position in this industry where, and in the science where there were tantalizing, insights into how you could put together a system for introducing genes into crops. You had Mary-Dell and her lab she came from, Gene Nesters and Mark Van Montague and Jeff Schell in Europe, who had worked on the agrobacterium system. You had other scientists who had worked on plants and who knew how to regenerate a plant from a single cell, which was a part of it. You had other scientists who were, working in animal systems on, developing the markers that would allow you to figure out which, whether you could put a gene in. And then you had the long, the real question in the background of what were you going to apply these tools to. And, we had a really privileged ability to interact broadly with scientists like Mary-Dell and others in the field. But I think the strength of an industrial program is you can focus, and we were able to pick, I think, the best features of many of these elements, and then put them together and say, how do you design a system to put it together and work? And we started out with that really important agronomic agricultural crop, petunias, which are displayed next door, and figured out how to get genes into petunia plants, and that kind of opened the door, years later for soybean and cotton. But I can remember all the meetings we used to have, and the science meetings. Gordon conferences were really popular. These were the week-long science conferences in all of the the schools on the East Coast, New Hampshire and Massachusetts and Maine, and we would, everybody would come together, across
All the people in the,
the whole field. I mean,
agricultural
and
field.
at that time, there was probably 100 people in the whole field. We would all come together. We would sleep in these really tiny beds that were about this wide. We would party too late at night, but Mary-Dell organized a bunch of them, and she would, I was going to be nice, and she would always get us up at 8 o'clock, and we shared a huge amount of information, and everybody benefited, and yet we would still compete really hard, and at the next Gordon conference, we would share more information, and I think, the field kind of just came together to create the opportunity for the breakthroughs.
I want to add one thing. I agree with what you've told us, but I think one strength that industry has, and I'm in the industry now, I can see it clearly, it's the financial backing. This is an expensive thing to do, and it requires many different kinds of scientists working together. And you can amass that in industry in a way that's not possible in academia.
Yeah, it
So
was really
that's-
the reason I joined Monsanto, because I finished my my postdoc in San Francisco. I was looking for universities primarily to go to, but it was back then in the early '80s. There wasn't really a university opportunity where you had the molecular biologists, the plant tissue culturalists, the agronomists, who were all working together, and that's what it took to create that coordinated ability to really, put a gene into a plant, test it, regenerate it, do the breeding, do the work, and that's as you said, that's a real strength. Now today, the tools have gotten so much easier that startup companies and universities are much more able to participate. And I think when you look at the new advances like gene editing, that really opens the door for university science, I think, to really move into the crop and the agricultural world.
So I want to ask you about one sort of incredibly important moment that I'm sure you'll both remember. This is the
yes.
15th Winter Symposium. This is January 18th.
The Miami Winter Symposium.
Right. And
Remember that?
Remember that one well.
This is where, Mary-Dell, I've read where you said, this is the symbolic coming of age of genetic engineering. So two questions here. One, you'll see that Mary-Dell and Mark Schnell are on the program.
Jeff Schnell.
Jeff Schnell, but nobody from Monsanto is. So it'd be interesting to know how that happened.
But someone was.
Right, but somebody did. And then, of course, the bigger thing is, what did it feel like? I mean, this is one of these points. This is a turning point in life. I mean, this is a really big thing. What was that moment like? If I'd been in the room, what would I have seen?
I think we were feeling pretty prideful and cocky that we could conquer the universe with this technology, little knowing how many more obstacles there were yet to be discovered. It wasn't easy to go from the first genetically engineered tobacco or petunia plant to a real field crop that required.
I think it was cool. Also was so. Just to be absolutely candid, I wasn't there. The way we did
You were
it
in Miami.
It was Rob
the
Horsch.
way we did this was that our travel budgets were pretty restricted, so it was Rob Horsch's turn to go to the next meeting. So Rob went to the Winter Symposium, and it was really appropriate.
Did he bribe his way onto the?
No. If you remember, what happened was you and Jeff volunteered a part of your time so that Rob could speak.
Really?
So it was, it was really, I think, a wonderful moment where, and it's kind of like all how science comes to that head. I mean, all three laboratories, the Chilton lab, the Shell lab, the Monsanto lab, had demonstrated for the first time that we could introduce a new gene into plants and show that those genes behave like every one of the other 30 or 40,000 genes in the plant. And it was nice, I think, from both a science and from a historical sense, that all three laboratories presented basically at the same time.
Cool. We've got a picture of Boyer and Swanson, but you've really sort of covered this already, the notion of rolling out a business. So what I actually want to...
He never wore a tie. In the lab, when you would ride up on the elevator with him, he wore blue jeans, he had an old blue denim shirt, and he wore a leather vest, and that was Herb Boyer.
But the important thing here is that you both move into these commercial labs. Again, if I can quote you, an article you wrote said, the transgenic plants produced seeds that carried our transgenic genes to the next generation. This was the first genetically engineered plant. It was totally useless, but it showed we could do it. So, you know, between scientists making useless plants and business people making something that's going to change how farming is done, there's sort of like a big difference there. How did you make that leap?
Well, you see, Rob was in the industrial setting, and I was at Washington University when all that was going on. So my useless plant, what it had in it was what we call the phone clone. It's you'll call up your friend down the hall and say, have you got a gene I could use for this experiment? Any gene will do. And so someone gave me a yeast gene for alcohol dehydrogenase, and that's what we used to modify our plant. Totally useless. I mean, that's the gene that we use to detoxify when we drink alcohol, and my tobacco plants don't drink much. But it did show that you could do it, and that the trait would be passed to the progeny intact.
And that was the breakthrough. I mean, once you knew how to construct a vector that could put a gene in a plant, once you knew you could regenerate those cells into a plant, that genetic material that you introduced was stable and inherited like other genes in the plant, then you could broaden out to go from petunia to soybeans and corn, or from genes that were marker genes to to genes that could basically help plants resist insects and weeds. And that's where a lot of our focus was on, because, and the reason we picked those targets was, if you look at farming around the world, much of the food and crops that are lost or wasted are due to competition and damage by insects or competition by weeds. So, those were the problems we focused on, and I think those technologies have, in retrospect, have had a huge impact on farming.
All right, we're just about out of time, which is really sad because I've got like zillions more questions. But my last question for you is the one that probably most people want to hear you talk about. That really is about public reaction. Frankenfood. Right, this notion of Frankenfood. Do you actually know where the? It's interesting how the term. Well, I'm not going to bore you with it.
No, I don't know. I don't know where that came from.
It's a 1992 letter to the New York Times by an English professor named Paul Lewis. And here, what he writes is, ever since Mary Shelley's Baron rolled his improved human out of the lab, scientists have been bringing just such good things to life. If they want to sell us Frankenfood, perhaps it's time to gather the villagers, light some torches, and head to the castle. Now, the problem with this, it's a
Who's that? Mary Shelley?
well, it's an English professor talking about Mary Shelley, but that's exactly the point.
Is that me?
Is that he conflates fiction with reality, and in fact, in terms of public reaction, has often been based on visceral reactions rather than good scientists. So as I sort of talked to my friends in plant sciences and was bragging about having you here on the stage together and taunting them with what questions would you ask these two pioneers, one fellow said to me that what he really wanted to hear was, how do you operate in an environment of rumor and accusation and not scientific fact?
Sadly.
Do you think that, was this something that you anticipated as you rolled out genetically engineered plants, or is this something that's really, that you've just dealt with over time?
in my memory, I don't think we're thinking along those lines. No, I don't think so. How about you, Rob?
I'd say two things. If you would have asked me back in 1981 when I joined Monsanto, could I have anticipated back then that this technology today would be used basically on 95% of the farms in the United States, planted in 30 countries around the world, on a quarter of the world's farmland, and be the most rapidly adopted technology in the history of agriculture? I would never have believed it. On the other hand, if you would have asked me in 1981, would we still be addressing some of the questions on safety and benefits that we're still debating today, I wouldn't have believed that either. And I think the lesson that I've learned in all this through the years is that, and I say it basically this bluntly, that you clearly have to have outstanding science to create the kind of products that consumers, in this case farmers, want and benefit from. But I think if the one thing we've really learned is, along with outstanding science, you have to have outstanding science communication. And if there was something that I could have rolled the clock back and done differently, it's when we launched those first products 20 years ago in 1996, we put all of our effort into communicating to farmers about the benefits. And farmers have adopted this technology at a prolific pace, but we missed the opportunity to educate consumers, to get their support. And we're still paying the price for that, and it's clear that is the lesson to be learned from a lot of science. And we're focusing on GMOs tonight, but I've gone through the same experience with vaccination and anti-vaccine. I mean, there's half the population in this country who believes in the science around global warming and half who doesn't. I mean, I think it's really exemplary of what we need to do more. Here we are living in a period where the advances in science continue to skyrocket, and the understanding and the communication of science just hasn't kept up. And that's, I think, our challenge. And it's really, I think, an important part of the history of this exhibit. Because almost everything you go through here from the agricultural world has originally been met with controversy, whether it was Norm Borlaug's short Mexican wheats trying to get into India, or the concerns over whether those first steel plows were going to leave iron oxide particles in the soil and poison the land. So, but in this particular case, with social media, that concern got to such a point that traditional approaches of dealing with it didn't work. And for me, that's the learning, is you have to bring great communication together with great science.
Great. Well, I think now we have a few minutes to take, if you're willing to take a few questions from our guest tonight. I think Catherine.
But you haven't asked the ultimate question.
Oh my goodness. What's the ultimate question?
Is it safe? And the answer, yes.
Well done. Well done.
Okay, now you can take your questions.
Please raise your hand if you have a question.
Hi, thank you. This question is for Dr. Chilton. And I just was wondering, you talked a bit about your experience in a lab and in universities, and I'd love to hear some of your experiences as a woman working in science during the time period that you were, and how that did or did not impact your experience.
Well, I guess, did everybody hear the question? I guess the main thing that impacted my career was my two little boys. You have to spend some time with your kids. I solved that problem by talking to the boys and talking to myself. And what I said was, when I'm in the lab, I'm going to be wholeheartedly in the lab, think about that. And when I'm at home with my kids, I'm not going to think about the lab. I'm going to think about the kids. And I divided my time that way. In addition, I've left out that I had a solid gold husband who took care of the
Mary-Dell was an amazing advocate, not only for the science, but for women in science. And, you know, she blazed a pathway that I'm sure was a real difficult one. And, you know, the impressive thing about Mary-Dell is she's still in the laboratory today doing science, and that's pretty cool.
That's very generous, but I think it's, you know, I just did it.
You did. I
couldn't-
agree.
I couldn't not do it.
Yep.
You know, it's a compulsion.
We have another question over here.
So you talked about the opportunity or the missed opportunity for more science communication when GMOs were introduced. And I know you're a scientist and not a communicator. I'm a communicator and not a scientist. How can, I really believe that the issue is not as much information as it is emotion. Food is a very emotional issue, and it's a very emotional subject to people. And it doesn't seem, as a communicator, it's hard to bridge that gap between information and emotion or overcome that. So as a scientist, how would you work with communicators to help bridge that emotion-information gap?
Great point. And today, you know, with a lot of the stuff going on with the continued need for communication, I probably spend about a third of my time communicating, doing debates, you know, reaching out. I would tell you, you're exactly spot on. Probably, you know, the most I don't know, disturbing or painful lesson I learned along the way, as a scientist and someone who's, you know, been involved with the discovery of this technology, is you can't bring science to an emotional discussion, and you have to connect with people at the emotional level. And you know, if someone's talking about their concerns over the safety of food that they're feeding their children, it doesn't do any good to talk about all the rat toxicological studies that you've done. You have to address people at that level and share, I think, you know, the common ground around, you know, your own passion for food security or for farming or for the environment. You have to connect at an emotional level, and that's key. And the other thing, of course, is you know, you have to connect with people in a content and a delivery sense that is the way they want to get their information. And you know, in a company like ours, when all this was going on and the internet was being developed and social media was exploding, I can tell you that, you know, corporate America, we're not experts on social media and how to communicate. And, you know, we're good at putting out press releases and writing reports and sending in regulatory studies, but not many people, you know, read those. And so being able to be much more fluent on social media, to be able to deliver the information content to people in the way they want it, I think is key. And I think as we look into the future, you know, with the statistics that you talked about, Peter, I mean, today in this country, less than 1% of the population is involved in food production. And the way I look at that is that means it's our responsibility and our obligation to reach out to that other 99% and tell them about the care, the passion, and the purpose that we have in producing food, and that's a big part of the message.
If I might add to what Rob said, I think another piece of it, in addition to the things you said, is that we need to show by our actions. We need to feed it to our grandkids, you know, show people that we believe that this is absolutely safe.
So, Dr. Fraley, I might direct this at you. Of course, acceptance has been a struggle, there's no question. What technologies haven't been developed that could have been if we had not hit the hurdles that we hit with public acceptance?
I think the biggest challenge that we faced with the hurdles has been it's escalated the regulatory requirements around the world. So, you know, if we're going to develop a new corn or soybean plant for U.S. farmers, you know, the way the system works is you do USDA, EPA, and FDA approval. I always kind of in jest say that if I were the head of a drug company, I would get FDA approval and I would sell drugs that people put into their bodies. Because we sell corn and soybeans, we get FDA, USDA, and EPA approval, but because, as you pointed out, the U.S. is the breadbasket for a large part of the world, we also get the Ministry of Agriculture, the Ministry of Health, and the Ministry of Environment approvals for between 50 and 60 countries that import food around the world. So the cost for development is huge. It costs us about $150 million to develop a new product. And the challenge is that that's hard for a university to do. It's okay to do that in corn or soybean or cotton or sugar beets, but it's hard to do it in tomatoes and peppers and other foods. So I think we've limited the adoption of the technology because of the extreme scrutiny and the redundant nature of the global regulatory system. That being said, one point I just want to make. I think we'll look back on this year and we'll recognize that this was a pivotal step change in the adoption of biotechnology products for 3 reasons. First one is, the National Academy of Science just completed a 2-year review of the 20 years of GMO history and basically concluded that the products are safe and they have benefit to farmers. And, just right after that, 100 Nobel laureates signed a letter talking about the benefits of these technologies. So the science and the safety question is really behind us. Another really pivotal thing has been, when President Obama signed the Safe and Affordable Food Act that established the national labeling approach. I think that will create the opportunity for transparency and consumer knowledge that has fueled a lot of the debate behind the debate. And then the third thing that I think we'll look at is this is the year where the next generation of GMO technology has captured everybody's imagination. I mean, how many times have you seen articles on gene editing, on CRISPR-Cas? And in many ways, that takes, what I describe it this way. What Mary-Dell and I did to put that first gene in the plant, with CRISPR-Cas technology, you can change every base pair of every gene in every crop or every organism. And it's going to be more sophisticated, it'll be more precise, and I think it takes us to the next level. So I think we'll look back at 2016 and say the safety question solved, the question on food labeling and public access to information has been solved, and we're already seeing the next generation technology take us to a new level. So I think it'll be a pivotal period for rethinking the whole acceptance of advanced biology in agriculture and food production.
Maybe this is the new 1983.
It is in many ways. I think you're right.
Yeah, that's good.
I think that's a great moment to stop.
Yes.
Really optimistic look at the future, and hope that people can enjoy themselves and informally chat with you for a little bit longer. I know that you have to leave soon, but if we can break from the stage and go down to the floor and join everyone else.
I want to thank all these wonderful people for listening to us. It's been
Well,
a trip down memory lane.
And the Smithsonian is really so honored to have the 2 pioneers of genetic engineering here. This is really, I can't tell you how much of an exceptional moment this is, that they're around the world. People are so envious to be here. So you're witnessing a very special moment. So thank you very much.